what you want is that you want to issue the warning that so and so area is highly having flood hazard. What warning I have to display? I have to display the warning that the specific area is having high flood vulnerability, right? And what I do, I prepare a signal writing 0.9 out of 1, or on a score of 10 I write 9, or on a score of 10 I write 9, and display all over the city with such numbers. Display, what I do, I put this board, let's say example of Surat city, which we have 6 zones and some more than 22 or 25 wards. So in each ward, what I do, I put numbers. Somewhere I write that the flood hazard is 9. In some areas, flood hazard is 8. In some areas, flood hazard is 7. In some areas, flood hazard is 6. Okay. So can anybody unmute yourself and reply that will this be will this make sense to general public? Hello. Someone of you unmute yourself and say tell me that if I put numbers in all the wards, okay, will it make sense to general public?
This may not be understandable by general public who doesn't know technical.
Yes, right, exactly. We do not know that the people will able to understand what we can say, what's the meaning of 9, or what is the meaning of 8, or what is the meaning of 6, right? So many of you may be feeling, sir, why fuzzy logic? Why we need to go for fuzzy logic, right? So one of the reason for this is that in fuzzy logic, it is not in terms of numerical values. It's a linguistic term. And
sir, your screen is not visible.
Yeah, I have not shared it. So linguistic means 9, 8, 7, 6, 5 numericals that may not be able to that the general public may not be able to understand. And therefore, if you have, instead of saying 9, you say that this particular zone have high flood hazard vulnerability, right? Or having high flood hazard vulnerability. Then immediately the general public will understand, yes, that the area in which I am saying that is highly prone to floods. While if I say low hazard vulnerability, then the people who are staying in those areas will feel that, yeah, we are staying into low hazard vulnerability, right? So what I am taking is not merely a theoretical topic. It has got practical application. And when I say that practical application, how it mean that it is a practical application, that first I have explained you, right? Now I will show you the example, first case study, that how we can take up or how we can apply fuzzy logic in identifying the flood vulnerable or flood risk exposure, that is flood risk exposure indexing of watershed using fuzzy logic. What I am going to do, instead of here I have taken watershed, somebody will take Nasik city, somebody may take Nanded city, Nanded town, somebody may say I take Amravati, somebody may take Nagpur, somebody may take some Akola, right? Some city or some town, and there you wanted to apply it and collecting data, you can able to do flood risk exposure indexing of that particular area. So here I have taken watershed, and for that watershed, how many watershed I have taken? 5 watersheds. And for 5 watershed, I have considered 1, 2, 3, 4, and 5 parameters. 5 watershed, and how many parameters I have considered? 5 parameters I have considered. That is slope, land use, land cover, soil, drainage density, and rainfall of that particular watershed. And these values which are written here, suppose for watershed 1, the slope is 1 in 20. Mostly it is covered by water. The kind of soil in watershed 1 is clay, the drainage density of that particular watershed is 0.011 and rainfall is 950 mm. This is the data which I have collected for watershed 1. So if you want to apply this, and if you want to keep this parameter for indexing any city, town, taluka, place, village, etc., you have to have that data for basic variables, right? Basic parameters. So the parameters which I am considering here for finding out flood, hazard, exposure, vulnerability. What I have to find out of flood, hazard, exposure. Exposure means how much that particular area is exposed to flood, right? And collecting this data for watershed 1, 2, 3, 4, and 5, I will be doing indexing using fuzzy logic, right? So that is our objective. So again, when we say slope in percentage, we need the data analysis for slope also. For example, as you see here, that slope in percentage, 0 to 25%, it is almost a plain terrain. 0 to 25, it's a almost plain terrain. Participant, please tell me, there are two slopes, one plain, another one steep slope. One is plain area, another is steep areas, having a steep slope area, where the inundation time for water will be more. Inundation, you understand? Spread of water and inundating area with water. Okay, so there are two slopes. One is plain terrain, another one is steep slope. So will you please tell me in which case the inundation time will be more, in plain terrain or in steep slope? Someone of you please unmute and reply. दो स्लोप है अपने पास में, एक एकदम प्लेन टेराइन है, right, and another one is a steep slope, right? So where the inundation depth or water retention will have more time, take more time than that of other. Yes, anyone? You can type in chat also. Yes, Milind Kumar has typed. No, means Milind Kumar, what do you mean by plain? Will it take inundation depth will be more or inundation depth will be less? In plain terrain, inundation depth will be more, Milind Kumar, compared to that of steep slope. Priyadarshani Mane, that too you have replied. So what do you mean by this? Hello. By 81 participants are there, only 2 are typing. That's all. Others are not typing. So out of 81, 2 means it is hardly 2%. बाकी सबको इंटरेस्ट नहीं है तो फिर सीधे वैलिडिक्टरी में आ जाओ, ऐसा करो. 3 replies, 4. I need 82 reply in question answer so that you can understand what I am trying to supply. Sushant is now awake. Sushant, I am saying that there are two slopes. One is flat terrain, another one is steep slope. My question is where the water inundation time will be more, in case of flat slope or in case of steep slope? Inundation time be more in case of flat slope or in case of steep slope? कितने आंसर आए? 1 2 3 4 5 6 आंसर आए खाली. हेलो भाई, 82 पीपल आर देयर. जागो आप लोग और आंसर टाइप करो चैट बॉक्स में. आई नीड एटलीस्ट 50% आंसर, देन ओनली आई विल गो अहेड, अदरवाइज आई विल स्टॉप टेकिंग दिस लेक्चर. दिस इज फॉर यू, दिस इज नॉट फॉर मी. खान जमील, हाउ इट कैन बी स्टीप स्लोप? स्टीप स्लोप होगा तो पानी रहेगा कि फटाफट निकल जाएगा? If it is a steep slope, what will happen? Water will inundate it, or water will flow, or it will have high velocities. If it is a plain terrain, velocity is low, so inundation will be for more time. And if it is a steep slope, what will happen? The water have high velocities and it will pass through the watershed fast, right? तो अब उससे आपको, I hope that now I got around 40 answers, so I continue again, right? So based on that slope in percentage, you can say if it is a plain terrain, indentation depth will be more. If it is a highly sloped, what will happen? The velocities will be high and the indentation time may be very less. Similarly, land use, land cover, already having water, already having agricultural area, built up area and forest. So depending upon what is there, the land use, land cover is there. So water depth, suppose built up area, right? Built up area with plain terrain. What will happen? The flood water may remain for hours together. The flood water may be there for days together. Similarly, type of soil, that is clayey, loamy, silty and sandy. Drainage density, that is kilometer per square kilometer, 0.012 greater than 0.151. And a rainfall, 500 less than 500 mm to 1100 mm. So if the more is the rain, less is the rainfall, probably the volume of water may be less and inundation depth may be less. While if there is a heavy rainfall like 1100 mm, what will happen? The inundation depth may be more because of during same time period 500 mm of rainfall fall over area or 1100 mm of rainfall fall over the area. So you understand clearly that how I have classified these 5 parameters to find out flood vulnerable exposure, flood exposure vulnerability or flood exposure indexing, right? So these 5 you understood. For these 5, again these 5 are classified into different classes, and as per these classes, what it affects? It affects the flood inundation depth. Okay, so this is the watershed, actual watershed, which, as I said, that it has been taken, and you can see that watershed number 1. So watershed number 1 is, this is my watershed number 1. You can see this red boundary. This is my watershed number 1, and this is the stream, right? Blue color is the stream, which is confusing here, right? This is my watershed number 2. This pink color, you can see that is my watershed number 2. Right, then green color, that is my watershed number 3. Okay, then this color, watershed number 4, and finally the watershed number 5, that is on the top. Okay, so this particular basin, which I have divided into 5 watershed: watershed 1, watershed 2, watershed 3, watershed 4 and watershed 5, right? And each basin has stream. You see that watershed 1 is having this stream, watershed 5 is having number of streams, drainage density is more, and it may be confluencing with it. Watershed 2, there is a kind of reservoir is there. You can see here the water is stored over here and it will continue here. Watershed 4, again, what you can say that it's have a tributaries and some dam is also there. You can see 1 or 2 bodies are there. So water bodies are more for watershed number 4, and watershed number 3, which is near to this particular stream, which is flowing in watershed 1 and watershed 4. So when there is a flood, the water may spread into watershed number 3. Okay, got it? Again, I will repeat quickly that what is my aim? My aim is to find out flood risk exposure indexing. Flood risk exposure indexing. For that, how many parameters I have considered? Land slope, land use, land cover, soil, drainage density, and rainfall. How many watersheds are there? 1, 2, 3, 4, and 5. What I am aiming to find out? I am to find out flood risk exposure. Right? Out of these 5, which shade is highly exposure to floods, and which watershed is less exposure to flood? That we wanted to find. How we want to find out? Using fuzzy logic. How we want to find out? Using fuzzy logic. So these 5 parameters, they have been divided into different classes, and these different classes have its effect on the flood inundation depth over a watershed. Okay, so after getting these watersheds, now which steps are required to follow to prepare what we can say flood exposure indexing? So the first parameter is input parameters fuzzification. Fuzzify all the input parameters. Combination of all parameters using fuzzy overlay analysis. This is a new tool, new topic. right? You can use fuzzy overlay tool, right, to find out the combined effect of all parameters, and it is known as fuzzy overlay analysis. And third step is ranking watershed on the basis of above analysis. All the parameters are needed to be converted to fuzzy values using membership function. Either you can use linear, trapezoidal, sigmoidal, p membership, s membership functions, etc. Membership function assign parameters scripts value to the range of 0 to 1. When you will do normalization of your data, your entire data will be in the class between 0 to 1. And again, depending upon your membership function which you have taken, the classes been made for the values of 0 to 1. 0 corresponding to very low value and 1 to very high potential risk of flooding. So what 0 and 1 indicate, that also I have defined. For the parameters given in the problem, we can develop positive function for two input parameters, that is rainfall and drainage density. Why positive function? Because rainfall increases, inundation depth increases. Drainage density increases, depth increases. While a function with negative slope for the remaining parameter, that is slope, land use, land cover, and soil type, that has been considered as a negative slope. So positive function for rainfall and drainage density, and negative function for slope, land use, land cover, and soil type. Right? After considering this, try to define what will happen to the slope. If the terrain is having steep slope, then flood water will be removed faster from the terrain, making it less hazardous to flood. Whereas if the terrain is plain, the water will remain for longer time, making it highly hazardous to flooding. Then land use, land cover. The watershed having high percentage of land cover of type water bodies will be having high chances of getting flooded as compared to land cover of types forests, where water will reach the drain slowly, thus delaying the peak. Soil type. The watershed made up of soil with high amount of clay content will make it difficult for flood water to infiltrate. If there is a built-up area or non-pervious area, what will happen? Depth will be more. If the permeable soil is there, what will happen? The depth will be less, increasing the flood hazard in the area, and that with soil type of a sand will allow flood water to shift fast, thus reducing the hazard. So ये जितने parameter है उस that also here we have listed with the flat, right? The inundation depth which we wanted to find it out. Drainage density, the watershed with high drainage density will increase the peak of flood, while low drainage density will reduce the peak. And rainfall, high magnitude of precipitation in a watershed will increase the flood. After understanding these 5 parameters, now we talk about the membership function. So membership function, linear membership function is defined like this: 1 or 0 when x is greater than maximum, it will be 1. 0 or 1 when x is less than minimum. And when the value is between 0 and 1, the membership function is x minus minimum upon maximum minus minimum. Similarly, S-step function, x is less than equal to a 0, a less than equal to x less than equal to a plus b. This particular function, a plus b less upon 2 less than equal to x less than b. This function, and when x is greater than equal to b, the value is 1. This we have used linear and S-step function. Now Z-step function. So for Z-step function, this is 1 x less than equal to a, 1 minus 2 x minus a whole square b minus a for this and the remaining one. So we have linear membership function, S-step membership function, Z-step membership function. Similarly, we have triangular membership function, trapezoidal membership function, etc. Right? But in this particular study, we have taken membership function as slope percentage. So I think for linear membership function, we have taken this slope, land use, land cover, and soil type, that is considered with linear membership function. Slope, land use, land cover, and soil type. This is considered with linear membership function. While the drainage density, that we have considered with a what we can say S-step membership function, that is S-step membership function. So after considering the membership function and rainfall also, we have considered the which membership function? S membership function. It is very important to choose membership function. Why? Because based on the membership function, how the membership function is to be chosen? the membership function is to be chosen depending upon how the parameter vary, right? And in when there is a high rainfall, what will happen? The flood depth will be more, right? Low rainfall, probably the infiltration is more, depth is less, and hence we have not chosen the linear membership function, either increasing or decreasing, but we have chosen the S type of membership function. So selection of membership function depends upon the variation of parameter, and depending upon how the parameter is varying, right? Whether it is varying linearly, whether it is varying in S shape, or whether it is increasing initially, then become constant and then decreases, right? Then trapezoidal. So that membership function you have to choose based on the parameter which you wanted to assess for fuzzy logic application. Okay. Then we have converted the values, which are the class values, and that we have considered in a fuzzy membership values. So 0.25, we said 1 to 0.75. So the slope is almost flat. The independent depth is more. So we assign value 1. And slope is high, very high velocity, right? Possibility of retention of water on a slope is almost 0. Therefore, we choose the value 0. Similarly, water, then flooding is possibility more. Forest, what will happen? The peak will achieve be slowly. So depending upon that, all the parameters, they have been ranged between, these are all called normalized value, values which we have collected from the field, that we will convert into normalized value. And if that normalized value lies between this specific range, this class be assigned to it, or depending upon that class, the fuzzy membership value will be assigned to that. Okay, that is the meaning of fuzzy membership value range. Okay, now fuzzy overlay analysis. The following fuzzy operators can be used as overlay aggregate to get flood hazard index as output. First fuzzy overlay analysis is fuzzy OR. The fuzzy OR is a maximum operator described by the union function based on the Boolean OR logic algebra, which takes the maximum membership, that is mu x, membership x, is equal to membership maximum of all the membership function A, B, C, D, etc. in meter. Fuzzy n. So fuzzy n takes minimum membership function, value of minimum membership function of all the values. Fuzzy sum is given as sum of membership values for each parameter. If you sum up the values which you have got for all the parameter, then it is called the fuzzy sum, or is given as summation of membership values for each parameter, which is fuzzy sum is used in the given problem. The output, that is flood hazard risk index ranging from 0 to 5, classify as very low risk if the value is between 0 to 1, low risk if the score comes out to be between 1 to 2, medium risk if it comes out to be 2 to 3, high risk which comes out to 3 to 4, and very high risk comes out to be between 4 and 5. So this is flood hazard index, that is indexing. So flood hazard indexing starts from 0 to 5, and the classes are very low risk, medium risk, high risk, and very high risk, right? So initially I said that if I write crisp value of 4.5 for a specific zone, general public may not be able to understand. But if you write very high risk, immediately the public will understand that this specific area is having high risk of flooding. Okay, then to analyze this, we have developed a MATLAB code, and that MATLAB code was developed to solve this problem, and since screenshot is attached here. So you can see this is the MATLAB code written here, and this MATLAB code is run with different values of what you can say the parameters, 5 parameters. So I will show you the MATLAB code that is written, and here we will run the model also. So for example, for Watershed 1, so Bhavin is my scholar who will be showing us that in the code how we can give the values and get the answer. So when we run, it will ask slope of watershed percentage, right? So For which watershed you are doing?
Watershed 1.
Watershed 1, we are entering the value, right? So slope of watershed 1 is 20%. Okay. Now it is asking type of land use land cover of watershed 1. So what is that? Water. So we will write 1. 1 is for water. Okay. And type of soil in watershed. So different type of soil. We have clay soil. So we will write 1. Drainage density of water kilometer per square kilometer. So the normalized value of it is 0.011. Right? And rainfall for this particular watershed, that is watershed number 1, is 950 mm. So when we run it, the score comes out to be 3.7552. This is the score. You will see it at the bottom of this, and we have classified it as a high risk of flood hazard. Right? Simply using the fuzzy sum function, we have worked out for all the parameters the flood hazard index, which comes out to be 3.7552, and according to classification, the watershed is at high risk of flood hazard. Right? If you want to do it for second watershed, right, we'll do it for second watershed. Again, we'll write run. For second watershed, the slope is 10. Then the land use land cover is 0, that is forest, or 0.75, that is the value depending upon the type of the cover. And then type soil, that is 0.35 silty. Then drainage density, that the value is 0.05, which comes and the rainfall, that is 850 mm. Right? So the value comes out to be 3.0679 for watershed number 2, and the watershed is at high risk of flood hazard. So MATLAB code has been written like this, very simple code, where MATLAB is not that difficult. You can also write depending upon the membership function, the linear membership function we have applied, accept membership function that we have applied, and we got I is equal to A plus B plus C plus B plus E. Right? That is fuzzy sum we have done, and we have worked out what we can say the watershed indexing. Right? So here you will see the values which we have computed using the MATLAB problem. Watershed 1, the flood hazard index has come 3.75, and flood hazard degree is high. For watershed 2, it is 2.95 medium. Watershed 3, 1.32 low. Watershed 4, 2.54 medium, and watershed 5, 2.11 medium. Okay, and this you can put it on the map. So you can see here that watershed 1 has a highly flood vulnerable area. Then second comes to be watershed 2, that is medium exposure vulnerability. Then watershed 3, which have low exposure vulnerability. Watershed 4, which have medium exposure vulnerability, and watershed 5, which have medium exposure vulnerability. So thus we can use the fuzzy logic, and of course the numerical values are also there, as I said in the beginning of the lecture, and I can put the board of this on in watershed 1, 2, 3, 4, and 5, but I do not know whether the general public will able to understand it. Instead of watershed 5, I write 2.11. Right here I write 2.11. I do not know whether the general public will understand or not. But the moment I write medium, high, low, right, very high, what will happen? The general public will immediately understand that how the area is prone to flooding, or what is the exposure probability of area to get flooded. Right? So this was the first case. If anybody have any question till here, can ask me. Any doubt anyone is having, please ask me. This is the first case, and I am very much sure all of you can do that. Actually, I wanted all of you to write this MATLAB code also, but because of lack of time, and probably many of you do not have MATLAB downloaded and installed in your laptop, right? I have done the calculation, I have shown the calculation through this particular screen. But if you have little time, you can do in the HTTP itself, here itself, right? So if you have any question regarding this, please ask me. Or else I will show you the second problem which is solved again using fuzzy logic. Hello, any question anyone have? Or if you have understood, type understood in the chat box so that I will go ahead. 90 participants are there, at least I should get 50 answers in the chat box. Have you understood what I am trying to explain using fuzzy logic? If you have understood, please type understood in the fuzzy logic or yes sir, then I will go ahead to show you the second problem which I have solved using fuzzy logic. Or you can type yes sir also. Out of 90, only 6 are typing.
Yes, sir.
Thank you. Others, please respond fast so that I can take the second example. Out of 90, now it is only 10. That is Mohammed, Jabir Mohammed, right? You please refer fuzzy or and fuzzy sum definition with examples, right? In short, fuzzy sums add up all the values which you have come after the addition, and fuzzy or is the minimum of all the membership function it will consider. If we have 5 membership functions, and out of that, if you are applying fuzzy or function, it will pick up the minimum value. It will not sum up like fuzzy sum function. And if you use AND function, out of all the membership functions which you consider, it will take maximum function. So still I have not seen, I don't see that at least 50 yes sir in the chat box. I need at least 50 yes sir, then I will go ahead and explain the second problem. I need to scroll down. Yes, okay. Still I find that 30-40 people have written yes sir. Fine, no problem. I'll go to the another problem. Okay, that is also solved using fuzzy logic. So here, now this problem which we have solved here, that we have solved using fuzzy sum function. Here we have not applied fuzzy logic. Yesterday's class, right, that is reservoir operation. Can anybody tell me what was the limitation of that particular case study which I have explained you in my previous class? The case study which I have explained of reservoir operation, what was the limitation of it? Or someone of you may not have liked it. Why? I need answer of it. Now it's 91 participants. The case study on reservoir operation. हमने reservoir operation किया था, right? In that I have shown you all data सब बराबर था, right? But still there was some limitation. What was that limitation? If anyone has attended it properly and paid attention, proper attention, I think they can able to write in the chat box. What was the limitation of it? Okay, I give you hint. Fuzzy rules. Fuzzy rules. Anybody can make out now? Like this is like all of you may be listening to Radio City, and Radio City they ask this FM radios, they ask simple question, and answer of that question is almost known to 100 out of 90 listeners. Okay, similarly when I said fuzzy rules, right? So if you have attended the lecture critically or carefully, you should get the answer of this. Expert opinion, okay. Apart from that, Fawaz has tried and he said that expert opinion is required. Chalo, correct hai ye. This answer is correct. Apart from this, hello. भाई 3:15 को आपका वैलिडिक्टरी है, थोड़ा जल्दी आंसर दोगे तो I can complete the lecture within time limit. Only one guy has replied that fuzzy rules required expert opinion. Okay, tell me how many fuzzy rules were used for reservoir operation problem? Anybody remember it? अगर प्लस माइनस पता है तो भी चलेगा, लिखो. How many fuzzy rules were used in my reservoir operation problem? The case study which I have shown you on the second day. Hello. How many fuzzy rules I made? Can anybody write? No one. So what should I understand? Okay, it was 192 rules, right? And when it is 192 rules for around 3 or 4 parameters, too much, right? And if the rules are too much, because you have to write all the rules, and you have to write, and you are not sure that whether the written rules or rules are correct or not, right? That comes from the experts. But more will be the parameter. Yes, I have not shown the Gunwan Kate. I have yet not shown the screen. I am discussing that how many rules I made. 192 rules I made when I have explained you the reservoir operation problem on second day. That is on 22nd. And those rules are too much. And if you add the parameters, what will happen? This number of rules, fuzzy logic rule, that will go higher and higher, right? And therefore the problem which I have explained you in the first part, right, this one, which one? This one, where I have not used fuzzy logic. In this specific problem, third index exposure indexing, I have not used fuzzy logic, but I have used fuzzy sum function, and then I have solved it. Okay, and then I got this fuzzy sum membership function I have used, and then I have applied this particular function, and the watersheds were ranked. Right now, in the second example, this example is fuzzy rule based. This is not direct application as we have seen of fuzzy sum function in the previous case. This is not that. It is based on fuzzy rule based, right? And the numbers of fuzzy rules we restricted, that we made less, right? However, the process remains same. You need to input data, you go for the fuzzification, give weighted average interpolation, then made the fuzzy rules, right? Whatever answer comes, you have to do defuzzification, and finally you will get the outputs. So what we are trying to do here, we are trying to do rainfall runoff modeling, right, using fuzzy. Specifically in this case, fuzzy logic. What we wanted to do? Rainfall runoff modeling using fuzzy logic. Okay, so in this case, I have taken the example like this. The average annual rainfall for a region is 125 centimeter. That is 1250 mm, and maximum rainfall is 300 centimeter. Infiltration may occur not more than 80 centimeter. The basin is such that the infiltration is restricted up to 80 centimeter. The discharge for maximum rare combination of rainfalls has found to be 100 cumex. The maximum discharge is how much? 100 cumex. Derive a fuzzy logic model for predicting runoff, discharge in cumex for a prescribed range of rainfall and infiltration. Framed membership function suitably and fuzzy rules based on following data sets of rainfall, infiltration, and runoff. Right? The typical data set for 10 measurements are this. So you can collect more data from the field. If you want to develop a fuzzy logic rule based rainfall runoff model, I have taken only 2 parameters, rainfall and infiltration. You can take other parameters also which affects the runoff, and that you can include here in solving the problem using fuzzy logic. So right now, to show you the simple application so that you can go from part to whole, means you can solve a complex problem of rainfall runoff modeling considering more parameters the way the procedure which I am showing in this particular lecture. Okay, so this is rainfall values are given, infiltration values are given, runoff are given. So first you wanted to do normalization. So for normalization you need to have maximum value and minimum value of that particular data. So here rainfall, if you'll see all these, I think 66 is minimum, and in this the maximum value will see I think 280 is the maximum. Okay, similarly for infiltration also the minimum I think it is 10 and the maximum you will see here it is 63. For runoff, what is the minimum? Minimum is I think 11 and the maximum is I think 81. Right. So once you know the minimum maximum value, you can convert all these values into normalized value. Normalization means you have to convert the values between 0 to 1, the range of 0 to 1. Right. Then what he says that first you develop this model, and after developing this model, obtain the output when the rainfall is 213 centimeter and the infiltration capacity of soil at that time is 63 mm per hour. Second value is 320 centimeter and the infiltration is 70. Third is 1173 and the value is 40 mm. Fourth is 80 centimeter rainfall, infiltration is also low, 20. And when rainfall is 193, the infiltration is 36 cm. Right. So for the input parameters rainfall and infiltration and output parameter of runoff, we can develop a membership function of triangular type. Someone will say that why triangular? I want to take trapezoidal. Yes, it is possible to take. But for this example, to make you understand how the problem can be solved, I have tried to take a simple membership function that is triangular type. On the basis of train observation, given the parameters are divided in 3 classes, low, medium and high. How many classes I made? In the previous example, we made 5 classes. Now, in this example, I wanted to make it 3 classes, low, medium and high. The range is decided on the basis of minimum and maximum value of each observation, right? The range, how you can define the range? That, as I said, we find it out the minimum and maximum value. Considering that minimum and maximum value of each observed parameter, you can find it. So, group all the data of rainfall. देखो ये rainfall था 66 मिनिमम है और मैक्सिमम कितना है 280, तो उसके 3 ग्रुप बनाए, लो, मीडियम एंड हाई. 60 to 161 group, 130 to 230 another group, and 200 to 300 third group. Right. Then infiltration. So infiltration also we check the minimum and maximum value. तो minimum 10 है, maximum कितना है 63. तो again उसके 3 क्लास बनाए depending upon low, medium and high. 5 to 30, 20 to 45, 35 to 70. Right. And for runoff, we have the values. Minimum value is how much? 11. Maximum is how much? 83. So we made different groups, that is 60 to 100. अब मेरा group ready हो गया. So after classifying into group, now I will go for development of fuzzy logic model. So for this also again the MATLAB tool FIS editor fuzzy logic model has been used. In that, the first step is to give input parameters, right? So input parameters are 2, rainfall and infiltration. Fuzzy logic model, that is Mamdani inference system that have been used, and what will require? You will require runoff as output, right? If you have a laptop and if we have half an hour more time, you would have done this example along with me in this class itself. Right? It is not difficult. Sometimes it happens that people listen the word MATLAB and find it that, oh, it's a MATLAB, so very difficult. No, it's very easy. Ultimately, it's a mathematics, right? And engineers never are afraid by the mathematics. It's a simple programming. Once you learn it, once you do it for a small problem, you can use MATLAB for n number or n type, n varieties of problems, right? So here you have to choose. That somebody has asked me the question, sir, I want to understand OR parameter, right? So minimum of all the membership function. So AND method, OR method, implication method, aggregation method, defuzzification, right? So in all these you have to describe, or all these you have to give as an input to the model development, right? So defogification we have done with the centroid, right? And the range of all the parameters like rainfall, infiltration, runoff, all that you have to give here and you have to set it, right? That is output parameters. Once the model is developed, then the second step is the rainfall, the 3 classes we have done. So that 3 classes you can see that range and display range that you have to give here. What are the classes? Low triangular membership function 60, 110 and 160, right? That we have given for rainfall. Okay, for all the classes this is for low, then you change this range for medium, and then you change this for high. तो अगर हाफ एन आवर मोर होता और मैटलैब आपके लैपटॉप इंस्टॉल होता, आप लैपटॉप लेके बैठे रहते, दिस इज पॉसिबल टू सॉल्व इन दिस क्लास इटसेल्फ. ओके, देन दी similarly you have to give it for infiltration, similarly you have to give it for runoff. Okay, so this process you have to repeat 3 times. First input for rainfall, second input for infiltration, and third input for runoff. Once it is done, then you have to frame the rules, right? If rainfall is low, infiltration is low, runoff will also be low, right? If rainfall is low, infiltration is medium, runoff is low. If rainfall is low, infiltration high, the runoff is low. Rainfall is medium, infiltration is low, runoff is low. Rainfall is medium, infiltration is medium, the runoff is medium, and so on, right? So rainfall is high, infiltration is high, the runoff is low. But rainfall is high and infiltration is medium, then runoff is medium. And rainfall is high and infiltration is low, you can say that runoff is medium or runoff can be high. So these rules you have to frame as per your expertise, that what happens with runoff and rain infiltration combination, how you can get the value of runoff. So once you have made it, what you can go for, the model is developed, model is done, you can calibrate and validate with your observed data, and once it becomes finalized, you can give the required value. For example, 126, 60.8, runoff comes out to be 27.5. So this is the value here, it is given 125.9, 60.81, and for that, what is the runoff value? 27.5. So I will show you the input output. This program is also ready. So these are my input data for which I want the, what we can say, runoff. So first value is 230 and infiltration is 63. So what will be my runoff value? So this I am showing you in MATLAB screen. 1 minute. MATLAB no clue person. Hi. Desktop अच्छा. So the model has been developed here. You can see here the rainfall values, right? The membership functions, you will get it over here. आप ऊपर से भी तैयार है. Yes, these rules are there. See, wait a minute. So if you will see this first window, actually what we did, we directly imported the file because we have made the run the program, we have given the input data, we have given the output data, we have calibrated, validated model, and model is ready. So these steps which I have explained you, that I am not showing you. I am directly showing you now the model is ready, and now you wanted to give some input to it and want to get the answer, right? So this model is my model is ready. Now what is the first value? Let's see this 230 and 63. Okay, so in this we give you input 213 and 63. So this you will change. Here you write 213, comma 63. Okay, so see here automatically its rainfall is 213, infiltration is 16, and the runoff value, crisp value has come out as 41.5. Right? Then second value, what is the second value in the table? 20 and 70. So what is the value? 27.5. Then third value, that is 173 and 40, we will get the runoff value as 52.5. So this way, once the fuzzy editor has been used and the model has been developed, you can get all these values, all the answers, all the values like this 41.5, which we have designed at medium, 27.5 as a low, 52.5 as low medium, and 27.5 as low, 52.5 as medium. So how this medium low that has been come? Because we have given the classes in the beginning, right? This one, runoff, low, medium, and high value, and low, medium, and high value, you can have it over here. Okay, and this way you can use to find out runoff, that is rainfall runoff model that you can develop using the fuzzy logic tool, right? So I have shown you two cases for fuzzy logic application, right, which you can apply for solving the civil engineering problem, right?